We will start with the section 3 of chapter 11. Section 3 of chapter 11 is about energy conservation. Conservation. What's the meaning of conservation? Conserve. What's the meaning of conserve? If we think about energy conservation, the simplest and the real example that we have it is the roller coaster. Look, we have a different altitude. So the first one is the highest place, but did you guess that the place that the roller coaster stops has the same height? Let's see. So the first hill of the roller coaster is very high, maybe 20 meters, and the last one maybe 10 meters. So there's a difference between them. We have a potential energy before the moving of the cars of the roller coaster, which is greatest at the top. This potential energy is greatest at the top of the first hill. Then, this potential energy is changed to kinetic energy during the movement of the cars of the roller coaster. So, here, at the bottom of the first hill, the kinetic energy is less than the potential energy which is located on the top of the first hill. Wow. Then, the potential energy at the top of the second hill is less than the kinetic energy and potential energy of the first hill. Where does energy go? Where? So does energy get lost somewhere along this way? We don't know. Yeah, we know. The energy, potential energy, right, it's changed to kinetic energy, but also it's changed to another type of energy which is called thermal energy during the movement of the roller coaster on the track. So, by friction with the track and the friction with the air, changing the potential energy to friction, to thermal energy and kinetic energy. Then, this kinetic energy is changed to potential energy and thermal energy because of friction. So, where does energy go? It's become thermal energy. This energy that we think that we lost here, it's changed to thermal energy because of friction. Okay? So, does energy get lost somewhere along the way? No. It is just change. Energy can't be created or can be destroyed. It is just changed from one form to another form. So, this energy, because of friction, is changed to thermal energy. So, we have to know what's friction. Friction is a force opposite to motion. Look at this ball, it's moved to this side, and the force of friction is to this side. When two surfaces that are touching, between two surfaces that are in touching, the round and the ball is moved to this side, and the friction to this side, because of these two surfaces that are in touching and the movement of the ball. And some of energy is become thermal energy because of this friction. After that, we have the energy that's conserved inside the closed system. Closed system is like the roller coaster, like this one. It's closed system. We have to know what's closed system. It's a group of objects, like the tracks, like the cars inside this track inside this roller coaster, and we have objects that's transfer energy to each other. Closed system, it means you have a group of objects that transfer the energy, for example, from one object to the second one. And we have a law of conservation of energy. This law said it's law. It's not rule, it's law. Okay? This law said that the energy cannot be created and cannot be destroyed. It is just change. For example, we said the ultimate source of energy on the earth is the sun. The light energy of the sun, the thermal energy of the sun is changed to another type of energy. For example, it's changed to chemical energy during photosynthesis. It is changed to electrical energy by this panel that changed the sunlight to the electrical energy, which is called the cell. This cell that's changed to sunlight energy to electrical energy. So, for example, hair dryer, as we mentioned in the previous section, we said it's changed electrical energy to other types of energy. So this energy cannot be created. I mean, we can't create energy, okay? We can just change one type of energy to another, or we can't destroy it. For example, if someone died, the potential energy inside it or chemical energy inside the person is changed to the chemical energy inside the soil. So we can't destroy the energy, okay? So the law of conservation of energy, it means energy is conserved. It can be destroyed, it can be created, okay? So it is, we have to say the energy is changed just from one type to another type. And energy can be converted from one to another, as I said, but all of the different forms of energy in a system always add up to the sum total amount of energy. For explanation of this sentence, we have to move back to this one. Look, we have potential energy. If this potential energy is equal 20 joule, this one is just the example. I put the simple numbers, okay? And the kinetic energy here is equal 80 joules. So where's the 2 joules that we don't know where does this energy go? So we have to know, because of this friction, the roller coaster with the truck, friction, the cars with the air, 2 joule change to thermal energy. So the first energy that you have it must be equal the last energy, but by adding them. Look, this 20 joule is equal, it is changed to kinetic energy equal the friction, the thermal energy, which is 2, and it's equal 20. 20 joule, 20 joule. We can't create, we can't destroy. It is just change from potential energy to 2 different kinds of energy, kinetic energy and thermal energy. But maybe this thermal energy is useless. Okay. Okay, after that, may you have a question? Why is the conservation of energy considered as a scientific law? Why it's not rule? Why it's law? Because there is no exception in the world. It means in everywhere, one type of energy is changed to another type of energy, and some of energy is is changed to thermal energy because of friction, and there is no any exception for this law. It means on the earth or everywhere we can create energy or destroy the energy. Okay, we can just change one type of energy to another type. Energy is conserved within a closed system. This one is the simple example of energy conservation. Look, the electrical energy is changed to other types of energy. Here, the wire has become hot. Why? Because some of electrical energy is changed to thermal energy during transferring the electrical energy to the light bulb. And here, some of electrical energy is converted into light energy, and some other is converted to the after that, we have to know and we have to repeat that there is no conversion without thermal energy. And anytime one form of energy is converted to another form, some of the original energy always gets converted into thermal energy. And the thermal energy is due to the frictions or result from the energy conversion. And usually, unfortunately, it's not useful energy. Many scientists try to make the perpetual motion machine. Perpetual motion machine, it means it's the type of machine that you give for example, some amount of energy and you can take out the same amount of energy that you give it. But this one is impossible, unfortunately. Okay? So, constant supply machine, we have it like the drinking bird. It means every machine needs a constant supply for its working. Like this drinking bird that we have it constantly take the energy. We have a liquid at the bottom of the drinking bird, and the top of it's become wet during drinking the water. So when it is become wet, the liquids come to down and stand. But during increasing the temperature inside the room, here that we said it's wet, the water is evaporate to decreasing the temperature. By this way, the liquid is come to the head and cause the head to be down. By this way, it's called the constant supply machine. This is one example of constant supply machine, which is called drinking bird. By this way, you continually supply this machine by drinking the water. Okay, but we have to know that why perpetual machine is impossible. We said perpetual motion machine is the type of machine that's, for example, if you give 20 joule of energy, it can give you the same amount of energy back. This perpetual machine is impossible. Why? Because we said always there is the friction or there is a thermal energy, which is useless energy that's produced during changing or converting one type of energy to the other type of energy. And scientists try to make some machines with the energy efficient. For example, energy efficiency that we know that it's a comparison amount of energy before conversion and after conversion. For example, we have to try that the amount of electrical energy that's, for example, we have at the source, and then we have to measure it at the, for example, load. So how you can calculate the efficiency of this machine if there is a small amount of friction or small amount of thermal energy as the useless energy is produced. So it means the most of energy it's produced to the usable energy. For example, if you have a car, use for example gasoline to pass the same way. For example, if you have two cars to pass the same way, one in this shape and the other in this one is useless gasoline than this one. Why? Look at the shape of the car. This one is called aerodynamic because it has less friction with the air. And this one is more efficient. So scientists try to use the machines with the more efficiency, more energy efficiency. But look at this one. Oh, this one is not aerodynamic, or it's less aerodynamic. And this one is use more energy to overcome the friction with the air. Okay? So, and now scientists try to make new shapes with the aerodynamic and smooth surface for make the machines more efficient. After that, in summary, we have to say that because of friction, some of energy is always converted into the thermal energy during energy conversion, and energy is converted within a closed system according to the law of conservation of energy, and energy cannot be created or destroyed, and perpetual machine is impossible because some of energy always converted to the thermal energy because of friction. And this one is your homework. You have to solve all problems and answer all questions inside the section review. And the last homework that I have to you is a chapter review. So chapter review is page 260, 270. After that, I have one thing for you. Look, if you write school make me on Google, you have to search, just write school makes me. Google offers something for you. School makes me new. School makes me feel like sad, anxious, tired, cry, stressed, angry. Is it right? The last point that you have to add to search on Google, just write school makes me happy because of this situation that we have now.